This video is brought to you by mywayteaching.com.
In this part, we are going to study another important parameter, that is wavelength and angular wave number. See, the minimum distance between 2 points having the same phase is called as wavelength of the wave. Okay, the minimum distance between 2 points having the same phase, we call them it as wavelength, which is usually denoted by lambda. As you can see here, this is the symbol of wavelength, that is lambda. For simplicity, we can choose points of the same phase to be a crest or trough, which means if you consider a sinusoidal wave like this, the distance between two troughs, or the distance between two crests, we can call it as wavelength lambda. Okay. The wavelength is then the distance between two consecutive crests or troughs in a wave. If you take pi is equal to 0, then the equation will become at t is equal to 0, the displacement at t is equal to 0 will become the displacement. We already studied the equation for y of xt. That equation was a sine kx minus wt plus pi. So at pi is equal to 0 and t is equal to 0, the displacement will become y of xt is equal to a sine kx, isn't it? Yes. Since the sine function repeats its value after every 2 pi change in angle, we can also write this as sine kx is equal to sine kx plus 2n pi. Okay, that is equal to sine, if you take k common, x plus 2n pi by k. That is the displacement at points x and at x plus 2n pi by k are the same. The displacement at point x or at the point x plus 2n pi by k. The displacement at these 2 points are same when n is equal to 1, 2, 3 continues. The least distance between the points with the same displacement is obtained by taking n is equal to 1, the least displacement. Lambda, we can write lambda is equal to 2 pi by k, isn't it? Or in other words, we can write k is equal to 2 pi by lambda. So this is the equation that we use to find the wavelength. Lambda is equal to 2 pi by k, or k is equal to 2 pi by lambda, where k is the angular wave number or propagation constant. So in this equation we are seeing that k is nothing but angular wave number. or in other words we call it as propagation constant, and the SI unit of this is given by radian per meter. Okay, so this is about the wavelength and angular wave number. The wavelength lambda of a wave is the distance between the consecutive repetitions of the shape of the wave. For simplicity, we can say it as distance between consecutive crust or consecutive troughs. Okay. So now let us study about period, angular frequency and frequency. So you can see figure, that is an element of a starting at a fixed location oscillates in time with amplitude A and period T as the curve passes over it. So it is a sinusoidal plot, as you can see. It describes not the shape of the wave at a certain instant but the displacement of an element of the medium as the function of time, which means in the equation y is equal to x of t, that is displacement equation with pi is equal to 0, and you just monitor the motion of the element at x is equal to 0, then in that particular case we get y of 0 comma t, because x is equal to 0, is equal to a sine minus w t. So now that is equal to sine of minus theta is minus sine theta. So that is minus a sine of wt. So now the period of oscillation of the wave is the time it takes for an element to complete one full oscillation. Period t, you can see in this graph the time that is taken by the wave to complete one full oscillation. This is the one full oscillation. So the time, how much time it takes to complete this one oscillation is nothing but period of oscillation. So we can write minus a sine wt is equal to minus a sine w t plus t, where capital T is the period, that is equal to minus a sine, taking angular frequency inside, wt plus wt. Since the sine function, it repeats for every 2 pi, isn't it? So this wt is equal to 2 pi, or we can say w is equal to 2 pi by t. Isn't it? That w is what? Yes, w is nothing but angular frequency. Of the wave, and its SI unit is radians per second. The SI unit of this angular frequency is radians per second. The frequency V is the number of oscillations per second. This is angular frequency. If you count the number of oscillations, means how many oscillations are going to take place in 1 second, we call it as frequency, which is represented by the letter V. That is inversely related to time period. that is nothing but W by 2 pi. Okay. See, in all this explanation, reference has always been made to a wave which is traveling along a straight or a transverse wave. Whereas in a longitudinal wave, the displacement of an element of the medium is parallel to the direction of the wave. Here, the displacement is perpendicular to the propagation of the wave, whereas in longitudinal, it is parallel to the propagation of the wave, isn't it? So, that equation 1 of the displacement function for the longitudinal wave, we can write it as we can write it as so we can write s of x comma t is equal to a sine kx minus wt plus pi. So where s of x comma t is the displacement of an element of the medium in the direction of propagation of the wave at position x and time t. In this equation that we have written here, a is the displacement amplitude and other quantities have the same meaning as we studied in case of the transverse wave function, where k, x, w angular frequency, initial phase angle, pi a is the amplitude of the displacement. Okay. Now let us see one simple example here. A wave traveling along a string is described by y of x comma t is equal to 0.005 sine 80x minus 3t, in which the numerical constants are in SI units, that is 0.005 meter, 80 radians per meter and 3 radians per second. So in this problem, we must calculate first amplitude, second the wavelength, and the third the period and frequency of the wave, and also calculate the displacement y of the wave at a distance x is equal to 30 centimeter and t is equal to 20 second. So all the data is directly given. You just need to compare this with the displacement equation that we studied for a transverse wave. Then we can proceed with the solution. So first let us compare this equation to the displacement equation, that is y of x comma t is equal to a sine kx minus wt. Okay, and the in the question the equation they have given, that is y of x comma t is equal to 0.05 sine 80x minus 3t. So we can easily compare these two and we'll get the amplitude of the wave is given by 0.005 meter, or in other words we can write it as 5 mm, isn't it? And the second one is the angular wave number k and the angular frequency. So k is given by 80 and w is given by 3 radians per second. And then we should calculate the wavelength, isn't it? So for that we have a formula that is 2 pi by k. So we know the value of k. If you substitute the value of k, we get the wavelength as 7.85 meter. Okay. And last part of the question, we should calculate period and frequency. So we also know equation for period, that is given by 2 pi by w, and we know the value of angular frequency, so which is given by w is equal to 3. So 2 pi by 3 gives 2.09 second. This is the time period, and we know the frequency is reciprocal of time period. So if you do this, we get the value of frequency as 0.48 hertz. Okay. Now coming to the last part of the question, where they have asked us to calculate the displacement y at x is equal to 30 centimeter and time is equal to 20 second. So we know the value of amplitude A sine kx, and we know k 80 x they have given it is 30 centimeter, but if we should take it in terms of meter, so it is 0.3 minus w it's 3 and t they have given it as 20. So if you simplify this, we get sine minus 36 plus 12 pi. Sine 97 degree in degrees, which gives the value 5 mm. Okay.